So let's look at how to handle significant figures when we have multiple operations. So the example that I'm going to choose first has to do with the calculation of density. We know that density is mass divided by volume. So our operation is division. However, in some cases, we may have to use subtraction to actually determine mass of an object and subtraction to determine the volume of an object. So the example that I chose to illustrate this is I'm pretending I have a bunch of pebbles and I have a beaker whose mass happens to be 10.98 grams, and I add my sample of pebbles to this beaker and it ends up being 19.01 grams for the total mass. So to calculate the mass of my pebbles, I subtract and the answer I get is 8.03 grams. Now, to express this in correct sig figs, I've got to look at my last allowable significant figure of both measurements. And because my mass was determined on the same measuring device, both values have the last uncertain digit in the hundredths place. So when I subtract or add, my answer has to have the same precision as the least precise value. Since both of these have the uncertain digit in the hundredth place value, my answer needs to have its last allowable digit in the hundredths place value as well. So in this case, the calculator will actually give you the correct answer. Now let's take a look at my volume. Let's say I take these 8.03 grams of pebbles and I pour them into a graduated cylinder whose initial volume is measured to be 10.0 milliliters. When I add the pebbles, the volume goes up to 12 milliliters. So 2 milliliters is what is displaced by the pebbles, and that's the volume of my pebbles. Again, when I subtract, my answer has to have the same precision as the least precise value. Since the measurement was done in the same measuring device, both values have the 10th place as the last allowable digit. So my final answer has to have a place value in the 10th place value as well. Now, in this case, the calculator will not give you the correct sig figs. The calculator will merely say 2, but the 2 does not correctly reflect the precision of the measuring device, where the 10th place value is the estimated digit. So in this case now, I have done my subtraction for my mass and for my volume. Now I'm going to go ahead and I'm going to divide my mass by my volume to calculate my density. And this is the answer that my calculator gives me, 4.015 grams per milliliter. Now I'm going to apply my rules for dividing sig figs. And the rule is the answer has as many sig figs as the value with the least number of sig figs. My volume has 2 significant figures, and my mass has 3 significant figures. Therefore, my final answer must have 2 sig figs. So I look at the value that my calculator tells me. My 4 is 1 sig fig. This is my second significant figure place value. So I'm going to underline that to keep track of it. I look to the digit that is to the right of my 0, and since this digit is less than 5, it's 1, my 0 does not get rounded up. So the density expressed in correct significant figures is 4.0 grams per milliliter.